Hello seekers, welcome to my channel Science Seekers. Today we are going to discuss another interesting topic, that is forced electrical oscillator or driven LCR circuit. An LCR circuit fed by an alternating EMF is an example of an driven oscillator. In this figure, an alternating EMF E naught sin omega t has been applied in the circuit, where alternating EMF is E naught sin omega t, and that circuit containing an inductance L and capacitance C and resistance R in the series. Let small q be the charge on the capacitor at any instant and small I is the current. Small q is the charge and I is the current. Then the potential difference across in the capacitor is q by C. So the EMF due to the self inductance in L is L into di by dt. The potential difference is q by C. The self inductance in L is L into di by dt. The alternating EMF E naught sin omega t has been applied to the circuit containing an inductance of L, capacitance of C, resistance of R in the series. So the effective EMF in the circuit at any instant is given by E naught sin omega t minus q by C minus L into di by dt. Using Ohm's law, it must be equal to Ri. So E naught sin omega t minus q by C minus L into di by dt is equal to Ri. That expression is reduced to L into di by dt plus Ri plus q by C equal to E naught sin omega t. Differentiating the equation, we get L d square I by dt square plus R di by dt plus 1 by C into dq by dt equal to E naught cos omega t into omega. It means E naught omega cos omega t. dq by dt equal to I current. So this expression is reduced to L into d square I by dt square plus R into di by dt plus I by C is equal to omega E naught cos omega t. That is the differential equation of the forced electrical oscillator. It means once that transition effect dies away and a steady state is set off, then the current alternate with the frequency of the applied EMF but may differ the amplitude and phase. Hence, the solution of the above equation in the steady state of the form I equal to I naught sin omega t minus phi, that is equation 2, where I naught and phi are the constant we determine. Then differentiating equation 2, we get di by dt equal to omega I naught cos omega t minus phi. Then differentiating twice, that is d square I by dt square equal to minus omega square I naught sin omega t minus phi. Substituting the value of I di by dt and d square I by dt square in the above equation 1, we get minus L omega square I naught sin omega t minus phi plus R omega I naught cos omega t minus phi plus I naught by C sin omega t minus phi is equal to omega E naught cos omega t. So that above equation is reduced to minus L omega square plus 1 by C whole into I naught sin omega t minus phi plus R omega I naught into cos omega t minus phi is equal to omega E naught cos omega t minus phi plus phi. When we adding minus phi and plus phi, that is nothing change in that equation. So the right hand side will be omega E naught cos omega t minus phi into cos phi minus sin omega t minus phi into sin phi, because cos a minus b का formula. The equation must be true for all values of t. Hence the equation, the coefficient of sin omega t minus phi and cos omega t minus phi, we get minus L omega square plus 1 by C into I naught is equal to minus omega E naught sin phi, that is equation 3, and R omega I naught is equal to omega E naught cos phi, that is equation 3, and that is equation 4. Then dividing equation 3 by 4, we get tan phi equal to minus L omega square plus 1 by C by R omega is equal to L omega minus 1 by omega C divided by R. That is equation 5. Squaring and adding equation 3 and 4, we get I naught square whole into minus of L omega square plus 1 by C के whole square plus R square omega square is equal to omega square E naught square. So I naught square whole into R square plus omega L minus 1 by omega by C का whole square is equal to E naught square. So I naught is equal to E naught divided by root under R square plus omega L minus 1 by omega C का whole square. That is equation 6. Substituting this value of I naught in the above equation 2, we get I equal to E naught by root under R square plus omega L minus 1 by omega C का whole square into sin omega t minus phi. That is equation 7. This equation represents for the current at any instant of the circuit. This amplitude of the current is I naught equal to E naught divided by root under R square plus omega L minus 1 by omega C का whole square. So quantity root under R square plus omega L minus omega C का whole square is the impedance, that is Z of the circuit, where X subscript L equal to omega L, that is inductive reactance, and X subscript C equal to 1 by omega C, that is capacitive reactance. Thus Z equal to root under R square plus XL minus XC का whole square, and I naught equal to E naught by Z. So the case arises when X subscript L, when XL is greater than XC, then phi is positive, so the current lags behind the EMF. When XL is less than XC, phi is negative, then the current leads the EMF. When XL is equal to XC, then phi is equal to 0, that the current is the same phase. Current is the same phase of the EMF. The electrical resonance, when the current have maximum amplitude, then XL minus XC is equal to 0, then omega L minus 1 by omega C is equal to 0, then omega L equal to 1 by omega C, and omega equal to 1 by root under LC, that is the angular frequency. So this is for today's seekers. In further classes we will discuss another interesting topic. I hope you all understand the class. For any queries, do comment. If you guys like the video, just like, share and subscribe for more interesting topics in future. See you all in the next class. Thank you guys.